In this video, we're going to be going over airflow, negative pressure breathing, and the inhalation-exhalation process as a whole. To start off with, I just want to explain the passage of air from the nose and also the mouth all the way down to the alveoli. So when air is first breathed in via the nose or the mouth, it will pass through into the pharynx, which is a muscular structure that allows air to pass through the airways. It'll then go into the larynx, which is the voice box. Now, I've just drawn a little structure. This rectangular structure represents the larynx, and the larynx will have an opening hole here, and it'll also have a lid, which is known as the epiglottis. Now, the epiglottis will open when oxygen is being breathed in, and it will close when food and drink is consumed, such that they don't enter into the airways and they go into the esophagus where they're supposed to go. Once oxygen is breathed in through the larynx, it will go through the trachea, which is the windpipe, and then the bronchi. And the bronchi will divide into first the main bronchi, then the lobar, and then the segmental bronchi. And specific bronchioles will subsequently follow after that. The conducting bronchioles will divide the respiratory bronchioles, and finally it will go into the alveolar duct, the alveolar sac, and the alveolus in the lungs. I'm just going to also show you a diagram just to help understand this process a little bit better. So as you can see here, air passes through this bronchi, and there's the main bronchi, the lobal bronchi, and the segmental bronchi right here. Now, before I actually explain further, I just want to show you that this rectangle here represents the right lung, where there's three subdivisions: the superior, medial, and inferior portion of the lung, and then the left lung, which has the superior and inferior region with no medial region, and that is because of the cardiac notch. Now, that's not drawn to scale in this diagram. However, it's just to help you understand that a little bit better. So this is where the heart will be located. Now, air will flow through this bronchi, and at the segmental region will further divide into oxygen will pass through the conducting bronchioles. It will then pass through the respiratory bronchiole all the way down into the alveolar duct. And from the alveolar duct, further divisions will occur until oxygen enters the alveolar sac. And the purple small structures that I've drawn here represent alveoli. Now, alveoli, the key process that occurs is gas exchange. So outside of the alveolar sac, capillaries are located, and alveoli specifically will allow for the oxygen to diffuse into the bloodstream, and carbon dioxide will diffuse back from the bloodstream into the alveoli, and the reverse process will occur for waste to be removed. So the same way that oxygen passes through from the pharynx all the way down to the alveolus in the lungs, carbon dioxide will undergo the reverse process from the alveolus all the way to the pharynx and out of the mouth or the nose, whereas it's breathed out, the exhalation process. So the same way the inhalation process occurs, I just want to make really clear that the exhalation process occurs in reverse. So hopefully that makes sense. It's the dividing process, the conducting bronchioles, respiratory bronchiole, all the way down to the specific alveoli, and that is the process of how oxygen is inhaled and how it diffuses into the bloodstream. Now let's specifically talk about this inhalation and exhalation process. So before I talk about it, I just want to mention that the standard pressure at sea level is 760 milligrams of mercury. Now, the inhalation process involves the volume expanding in the thoracic cavity, however the pressure decreases. So for example, it may decrease to 757 milligrams of mercury. So air will enter during the inhalation process, and oxygen will enter the whole airway process that we talked about before, and the reduced pressure equalizes back to 760 milligrams of mercury. So it'll go from 757 back to 760 because of this oxygen entering, and therefore the pressure increasing back to what it was before. Now, the exhalation process is opposite. The volume will decrease and the pressure in the thoracic cavity will increase. So for example, it'll go from 760 milligrams of mercury to 763 milligrams of mercury. Air will exit in the exhalation process, and the increased pressure will stabilize back to 760 milligrams of mercury by the end of the exhalation process. So it will go from 763 milligrams of mercury to 760 milligrams of mercury. So hopefully that made sense. That's just a little bit about the negative pressure breathing process and how inhalation and exhalation actually works. And the specific muscles involved in inhalation and exhalation, I just want to make clear. The diaphragm, the first muscle involved in the inhalation process, is a muscle located at the bottom of the thoracic cavity. Now, I've actually drawn a little diagram just to really illustrate the diaphragm's structural change between the inhalation process. So this curved structure represents the diaphragm at its prior to inhalation, it's non-contracted state, and when it contracts during inhalation, it'll actually straighten like this. So you can see that I've just drawn the right and left lung just to illustrate the diaphragm in the context of which it operates. So it'll, from this curved position, it'll actually straighten to allow for an increased thoracic cavity, to allow for greater volume and a decreased pressure like we talked about before. The external intercostal muscles are also involved, and these are muscles that are located outside of the rib cage that allow for the thoracic cavity to expand and for that negative pressure breathing process to occur. Now, during exhalation, it's quite a passive process where the diaphragm will relax back to its original state. However, during processes such as coughing, specific muscles, and forced exhalation processes, muscles such as the internal intercostal muscles, so the muscles located on the inside of the rib cage, and the abdominal muscles are engaged. And these muscles reduce the size of the thoracic cavity and will allow for the forced removal of carbon dioxide and the forced exhalation process. That is everything that we're going to be covering in this airflow, negative pressure breathing, and inhalation and exhalation video. Hopefully this video helped you understand these concepts with a little bit more clarity, and it definitely helped me understand it better as I taught it. With all that being said, that's all we're going to be covering in this video.